Hello everyone, hope you're all doing well. This is Vidyashri. So here I am before you today with an excellent trick to solve questions related to rate of a chemical reaction. So using this particular method, you can solve the question on rate of chemical reaction without any confusion. So let us study this particular method of solving a problem by considering an example. So the question is, ammonia and oxygen react at high temperature according to the equation 4NH3 gas plus 5O2 gas giving 4NO gas plus 6H2O gas. In an experiment, the rate of formation of NO was found to be 3.2 into 10 to the power minus 3 mole per liter per second. Calculate the rate of formation of H2O. So in this particular question, they have given us a chemical equation. Also, they have given us rate of formation of one of the product, and they have asked us to find the rate of formation of another product. So similarly, they can also ask us to find the rate of decomposition of any of the reactants as well. So we all know that rate of a chemical reaction is equal to decrease in the concentration of the reactant divided by time taken, and this is also equal to increase in concentration of the product divided by time taken. So now let us write the rate for the given chemical equation. So for the given chemical equation, rate is equal to decrease in concentration of the reactant, because during a chemical reaction always the concentration of reactant decreases and products are getting formed, therefore concentration of product increases. So here we have the concentration of reactant that is decreasing with the time. So it is minus delta concentration of NH3 divided by time taken, that is delta T. So since we have the stoichiometric coefficient 4 with respect to NH3, we have to write minus 1 by 4. So instead of writing that in the front of delta concentration of NH3 divided by delta T, I'll write it in the denominator. So it is divided by 4. So which is equal to decrease in the concentration of reactant. We have one more reactant, that is minus delta concentration of O2 divided by delta T. So similarly, formation of products. So products are getting formed. So the sign is positive. Delta concentration of NO divided by delta T. So this is also equal to the formation of product, increase in the concentration of one more product. So that is plus delta concentration of H2O divided by delta T. So now whatever values of stoichiometric coefficients we have in the given chemical equation, we will write them in the denominator. So the stoichiometric coefficient corresponding to oxygen is 5. So this divided by 5, and corresponding to NO is 4. So divided by 4, and that of corresponding to water is 6. So this is the rate equation. Now we have written rate equation without any confusion. Otherwise, how we used to write? Instead of writing this particular value, we would have written minus 1 by 4 delta concentration NH3 divided by delta T. So if we had missed the value of stoichiometric coefficient, we will definitely go wrong in our calculation. So to avoid this confusion, instead of writing the stoichiometric coefficient together with the concentration terms, we will be writing it separately in the denominator when we write the rate law. Now coming back to the question. So they have given us the rate of formation of NO. Rate of formation of NO means it is plus delta concentration of NO divided by delta T. So this value is given, that is 3.2 into 10 to the power minus 3 mole per liter per second. They have asked us to calculate the rate of formation of H2O. Rate of formation means plus change in concentration of H2O divided by the time taken delta T. So this is what we need to calculate. Now from this rate expression which we have written for the given chemical equation, let us pick the value that is given to us in the question and what we need to determine. So here we have plus delta NO divided by delta T divided by 4, that is equal to plus delta concentration of H2O divided by delta T, which is divided by delta 6. So these two are required for us. Let us write it separately. Rate of a chemical reaction is equal to decrease in concentration of the reactants, which is equal to increase in concentration of the product. All these are equal. So from the rate expression which we have written, we can consider any two expression and we can evaluate them. So I can write, as we are given with the rate of formation of NO and we need to calculate the rate of formation of water, I have considered these two equations from the rate expression that I have written. So here the rate of formation of NO is given to us in the question and we need to determine rate of formation of water. So rearranging this equation, I can write delta concentration of H2O divided by delta T. So that is equal to, taking this 6 to the other side, I can write 6 by 4 into plus delta concentration of NO divided by delta T. This concentration of delta NO divided by delta T is given to us in the question. So substituting that, we have 6 by 4 into 3.2 into 10 to the power minus 3. The unit is mole per liter per second. Simplifying this, 2 ones are 1 and it is 1.6. So 3 into 1.6 is 4.8 into 10 to the power minus 3 and the unit is mole per liter per second. And the answer for the formation of H2O is 4.8 into 10 to the power minus 3 mole per liter per second. And in the similar way, we can solve for the rate of decomposition of oxygen as well as for the rate of decomposition of NH3. Similarly, now if we want to find out the rate of decomposition of oxygen, so from this expression, I can write it as, so this is for decomposition of oxygen. So now it is rate for decomposition of oxygen. So it is minus delta concentration of O2 divided by delta T divided by 5. This is equal to We are provided with the rate of formation of NO. So plus delta concentration of NO divided by delta T, which is divided by 4. So rearranging this, rate of decomposition of O2, it is minus delta concentration of O2 divided by delta T. Rearranging this, taking phi towards the right hand side. So we have phi divided by 4 into plus delta concentration of NO divided by delta T. So we have 5 by 4 into, and the rate of formation of NO is given to us in the question. It's 3.2 into 10 to the power minus 3. So simplifying, 0.8, it's 5 into 0.8, that is 4.0 into 10 to the power minus 3, and the unit is same as that for the rate of formation of NO, it is mole per liter per second. So if they ask rate of decomposition of O2, the answer is 4 into 10 to the power minus 3 mole per liter per second. Similarly, if they ask for rate of decomposition of NH3, so this is for rate of decomposition of NH3. So we can write minus delta NH3 divided by delta T, which is divided by its stoichiometric coefficient 4, that's equal to rate of formation of NO is given, so delta concentration of NO divided by delta T, which is divided by 4. So upon rearranging, this 4 and 4 gets cancelled, and therefore rate of formation of NO is equal to the rate of decomposition of NH3, and therefore rate of decomposition of NH3 is equal to rate of formation of NO, that is 3.2 into 10 to the power minus 3 mole per liter per second. So this is how you can easily solve the questions related to rate of chemical reaction without any confusion. So what you have to do is you have to just write the stoichiometric coefficient in the denominator part of the rate expression that you write from the given chemical equation. Here is another question. Just pause the video, go through the question, solve it, get the answer. Then play the video, check whether you have solved it right. Question is, for the reaction 2A plus B giving 3Z, if the rate of consumption of A is 2 into 10 to the power minus 4 mole per liter per second, the rate of formation of Z in mole per liter per second will be option A 3 into 10 to the power minus 4, option B 2 into 10 to the power minus 4, option C 4 by 3 into 10 to the power minus 4, option D 4 into 10 raised to minus 4. So they have given us the chemical reaction. It is 2A plus B giving 3Z. Now let us write the rate equation for this reaction. Rate of reaction is equal to decrease in concentration of reactant minus delta A divided by delta T, that is equal to minus delta B divided by delta T, which is equal to the rate of formation of product plus delta concentration of Z divided by delta T. Now we have stoichiometric coefficients. Don't forget, let us write in the denominator. Here for A, the stoichiometric coefficient is 2 and for B is 1. For Z it is 3. Rate of consumption of A is given by minus delta A divided by delta T, that is equal to 2 into 10 to the power minus 4 mole per liter per second. We are asked to find the rate of formation of Z. The rate of formation of Z is plus delta concentration of Z divided by delta T, which is equal to what we have to find. What is the value we shall find now? From the rate expression, we can write minus delta concentration of A divided by delta T divided by 2 is equal to plus delta concentration of Z divided by delta T divided by 3. So we can rearrange this to find the rate of formation of Z. Shifting 3 to the other side, rate of formation of Z plus delta concentration of Z divided by delta T equal to 3 by 2 into rate of decomposition of A minus delta concentration of A divided by delta T, which is equal to 3 by 2 into rate of decomposition of A, 2 into 10 to the power minus 4. The unit is mole per liter per second. We are asked to find the unit in terms of mole per liter per second. 2 and 2 gets cancelled. 3 into 10 to the power minus 4 mole per liter per second. Therefore, the right answer is A, 3 into 10 to the power minus 4 mole per liter per second. In this way, if you write stoichiometric coefficients of reactants as well as products in the denominator of the rate expression, you can solve the question without any confusion. I am hoping that you have understood this method of writing rate expressions for chemical reactions. I hope you will find this method easier than the previous method how we used to write the rate expression. I'll meet you in the next video with a new trick. Thank you for watching. Stay connected, keep learning, take care, bye bye.